So a little bit about tape back tension. See this lever here in this VHS machine. Now if you look at the audio cassette, it has a felt pad which presses the tape against the head for good tape to head contact. But yeah, with a helical scan unit you cannot put a felt all around the head, so you need another system, and that is where the back tension comes into play. For demonstration I have here a chassis of a Philips turbo drive. You can clearly see here the lever with the back tension band. The tape is wrapped around this pole here, and the tape tension acts on this spring, and this spring is converting a force here generated by the tension of the tape to a distance here. So the tighter the tape gets, which is detected by the force in the spring, the looser the band gets and the easier this will spin. So now I have zero tension because there is no tape at all, providing maximum torque. And when I have a high tape tension I have zero torque. So the tape is wrapped around there, registering, measuring the tension. And then we have, when we are going backwards for play and reverse, we have an extra brake here. This lever here provides the back tension when it's going in one speed reverse. Now why is this dynamic? That is because the diameter of the spool is changing. So for example with if this is my spool and I have only a little bit of tape on it, so this is the tape, then I have here a certain arm with a certain distance and a certain force, and that creates a torque. So the brake torque is F times D. With a full tape, my D becomes larger, or with a full spool. So that means my tape is running near the at the beginning of the tape. It's all the way wounded until there, and the goal is to have a constant F, a constant force for the tension. Let's call that force tension, but with a varying distance there. So my torque needs to change to compensate for the changing D distance to get a constant force. So that's the idea of the brake. The brake torque is changing to get a constant tape tension. And yeah, to be able to measure it and to set it up correctly, to measure directly the tape tension would be difficult. There are some special tapes to do this with the measuring gauge in it, but yeah, they are hard to find and the readout is not so reliable. I heard. So in the service manual of this unit, Philips Charlie mechanism is mentioned a real convenient way how to do this. So yeah, this is a unit I used for parts. So I took a lot of parts from it, but I decided to restore it. I made some brand new axle in here for the tape lift out of a bicycle spoke. Brand new pinch roller, new capstan. I took some pieces of board out once, but I put it all back, and this is OSD unit. And a new gear here. This shaft under the pivoting wheel always needs a drop of oil against squealing. But anyhow, let's see if I can demonstrate the effect on the tape tension. This one is perfect still because of the 3 heads. Yeah, that's better. So in order to do the tape tension, you need a screen with a horizontal adjustment. And this one happens to have this. Sometimes it's inside your television or monitor, or there's nothing at all. This distortion at the bottom is actually the head switching point, so we're going from the one head to the other. And then you see this little jump here. Now let's assume we're playing a tape from a known good machine, or maybe a movie that's recorded by a professional machine, or an alignment tape, or anything you're sure of. It's recorded with a good back tension. Now I'm going to hit the pole. I'm going to play with the pole here to adjust the back tension by purpose. So just to demonstrate what it does. So now you see the jump here is minimal. Now I'm increasing the back tension. You see the jump goes to the right. Now I'm letting go again. Now I'm loosening the back tension. Jump is going to the left. So there is a clear midpoint here, where the lines, where my color bar is aligning when switching from the one head to the other. So that's going one way, letting go, going the other way. A clear midpoint, and that's a very convenient way how to do it. In the service manual is stated the jump should be less than 8 microseconds with it, which is the width of one bar. But so in the way that works, as far as I understand, so when this is the tape, we are scanning, let's say, head 1, and after this we are scanning head 2. And we have in this trace a lot of horizontal pulses. So let's say those are my horizontal pulses. And when switching from head 1 to head 2, so let's say here we go from head 1 to head 2, and then the next horizontal pulse comes, and by the way, after this comes the somewhere in the future, after a few lines, the vertical pulse, frame sync. But the goal is to have this length between horizontal pulses equal to this, and then when they're not equal, so this is the horizontal sync, when this length is not equal, you see the jump in the bars that I showed you. So that's how I guess this works. So if I'm totally wrong, please let me know in the comments. Oh yeah, there is one more thing. So what we can see is that the spring can be adjusted, but sometimes also the length of the belt can be adjusted, and that has to do with this. So if we would have the pole with so this is the tensioning pole, it should be something like this. It's mentioned in the service manual, what the balanced position, so during play what the position of the pole should be. But let's demonstrate this with an extreme. Let's say the tape is doing this, then the force on the pole is double the force on the tape. So F tape, and here is again F tape, F pole. So F pole is 2 times F tape. And in the other extreme, when the tape is running like this, then we have here the tape tension, and here an F pole of 0. So and that's what you can do with the length of the band. You have to sort of be in the middle of this and this to be able to correctly measure the tape tension. And so for this one, it's the spring is here, so that's for the force on the arm, and then there's usually another adjustment for the length of the belt. So yeah, that is that. What was I going to? Oh yeah, the unit in this one. The goal is about 40 grams centimeter. But that should be the braking torque, but there's no way for me to measure it. So yeah, that's it.